This is an exponential application with doubling time. It works a lot like half-life, except it's growth instead of decay. So here the example states a bacteria culture initially contains 1,500 bacteria and doubles every half hour. The two tasks we will perform are how many bacteria are there after 60 minutes, and the same question for after 8 hours. Now, like the half-life, this has a shortcut model. So I'm going to use the shortcut, and that is that the amount at time t is the initial amount times 2 to the t over the doubling period. So A is the initial population and D is the doubling period or doubling time. So we have the initial population given to us is 1,500, and the doubling time is a half hour. So 30 minutes or 0.5 hours. Completely up to you how you decide to use this, minutes or hours. Whatever you use, you have to be sure that your units are consistent. So notice task 1 asks the question in minutes, and task 2 asks the question in hours. So make sure that if you are using minutes in your model, that you convert everything to minutes, and if you're using hours, you convert everything to hours. So in minutes, the model would look like this. P is 1,500 times 2 to the t over 30. And in hours, the model would look like this. P is 1,500 times 2 to the t over 0.5. Doesn't matter which one you use as long as you keep units appropriate. I think that hours is cleaner in this particular problem. So I'm gonna keep this one. I think it's more elegant, I guess you could say. And that's because 60 minutes is easily converted to 1 hour, and dividing by 0.5 makes the numbers cleaner. So the model I'll use is P is 1,500 times 2 to the t over 0.5, and dividing by half is the same as multiplying by 2. So actually simplifying makes it look much cleaner. So in task 1, 60 minutes is equal to 1 hour. And so we'll plug in 1. This is P is 1,500 times 2 to the 2 times 1, which is 2 to the 2, which is 4. 4 times 1,500 is 6,000 bacteria. The second task, 8 hours. Plugging in 8, we get P is 1,500 times 2 to the 2 times 8, which is 1,500 times 2 to the 16, which comes out quite large at 98,304,000 bacteria.